Hey everyone, welcome to Data Intellect Solutions. Today we are diving into 5 powerful DAX functions that will revolutionize how you analyze your data. We have got a dataset ready and I'll walk you through each function with clear examples. Let's get started. Here's our simple dataset. We have a sales data table with the following columns: order ID, date, region, product, and sales amount. This dataset will help us explore, calculate all calculatable if and Rankx DAX functions. First up is the calculate function. This function modifies the filter context of calculation. It's crucial for advanced analytics. Let's simplify what calculate function does. Imagine you want to perform a calculation but only under certain conditions. For example, you might want to sum up sales but only for a specific region or product. That's where calculate comes in. It helps you modify the context of your calculations by applying filters so you get the results that matter most to you. Now let's look at the syntax of calculate. Here's how it's structured. Calculate, and then we have to give expression, and then we have to apply the filters. Expression. This is the calculation you want to perform. It could be sum, average, or any other aggregate function. And the filter parts are the conditions you apply to filter your data. You can use multiple filters to refine your results. Let's walk through a step-by-step example using our dataset. Our dataset has the following columns: date, order ID, product, region, and sales amount. We will now create a new measure in order to find the sales of the North region. We'll click on sales data and we'll click on new measure. It will take some time. Here we will insert our DAX formula for calculating the total sales for the North region. We will first rename this measure and we will write total sales North. Now let's insert our DAX function that starts with the calculate keyword. Then we will insert our expression, that is sum of the sales amount. And then we will specify our condition, that is our filter, that we want to find the sales across the North region. So we'll insert region column here. And we will insert the keyword North because we want to find the total sales across the North region. We will press enter. And this will create a new measure called total sales North. The first part of the syntax calculate the total sales across all the regions, and the second part is the filter part that restricts the calculation to the North region only. We can see that we have a new measure created in our sales data table, and in order to visualize this measure we will select a visual, that is our card visual, and we will insert our new measure in the feed. You can see that it has calculated the total sales across the North region, that is 60.42K. To sum it up, calculate is a powerful BI function that lets you modify the filter context. Next up is the all function. Imagine you have a report with slices or filters applied and you want to calculate a value that ignores these filters. For example, you might want to show the total sales across all regions even if your report is filtered to just one region. That's where all comes in. It removes filters from one or more columns or tables so that you can see the unfiltered totals. Now let's look at the syntax of all. Here's how it's structured. We have the keyword all and then we have to insert a table or column. This specifies the table or column for which you want to remove the filters. You can use it to remove filters from a single column, an entire table, or multiple columns. More concrete, let's walk through a step-by-step example using our dataset. Our dataset consists of the following columns like date, order ID, product, region, and sales amount. We will first apply a filter to this page and we will select the region column and drag it to the filters on this page, and we will select the north region as a filters since we want any data that is displayed on this page is restricted to north region only. Now we will calculate a new measure and we'll select it. It will take some time. And now we will rename this measure as total sales since we want to find total sales using the all and calculate function. We will use the calculate function first in order to sum the total sales amount, and then we will use the all function to remove any filters on this page. So let's first use the calculate function. And now we will insert our all function in order to remove any filter applied to the region column. We will press enter. And we can see that a new measure has been calculated and created in our sales data table. We will now want to visualize this in order to see whether the all function has removed the filters applied to this page. We will select the card visual and we will drag our new measure, that is total sales, in the fields, and we can see that it has calculated the total sales despite of the filter that is applied on our region column to this report. This means that all functions remove any filter that are applied on the reports page and give us the original values. Now let's explore the Calculatetable function. This function is used to return a table that has been filtered based on a specific criteria. It's particularly useful for creating dynamic tables based on complex conditions. Here is the syntax of Calculatetable. First, we will get a keyword Calculatetable and then we will insert the table name and then we will apply the filters. The table keyword is the table that is to be returned, and the filters are the conditions to apply to filter the table. Let's see the usage of calculate table with the help of example. Suppose we want to create a new table that shows the sales data for the North region only. For that purpose, we will select our sales data table and we will create a new table. This will take some time. We will rename the table name and we will write not table as a new name of the table. We will insert the keyword calculate table and the name of the table that is to be returned, that is sales data, and we will specify the filter with the region column north since we want to filter out the north sales and want to create a table that returns the sales amount for the north region only. We will click enter and this will create a new table with the name north table. You can see that a new table has been created with the name north table and it has same columns as we have in the sales data table. Now in order to visualize our data, we will select the table visual and we will insert the region column and the sales amount column in the columns field, and we can see that the visual only displays the total sales across the north region because this calculate table function has only returned the total sales amount for the North region. Finally, let's discuss the if function. The function allows you to perform conditional logic in your DAX calculations. For instance, you can create a column that classifies data based on specific criteria. Here is the syntax of if. First, we will insert the keyword if, and then we will insert the condition, that is the logical test to perform, and then we will insert the value if true. This value returned if the condition is true. So we want to insert the value that we want it to display if the condition is true. And the next is the value if false, the value returned if the condition is false. Let's see how the if functions works. Suppose we want to create a column that classifies the sales amount as high and low based on a threshold. For this purpose, we will create a new column that will do this classification. So click on the sales data and then click on the new column in order to create it. We will now rename this column as sales classification. And we will write our DAX function that starts with the if keyword. We will insert the logical test. Since we want to classify the sales amount, we will insert the table name, sales data, and the sales amount, the column name. Okay, so if the sales amount exceeds the 5,000 amount, the value to be returned should be high. And if the condition is not true, it should return low. So if the sales amount is less than like 5,000, it should return low. And we will hit enter, and we can see that a new column has been created with the name sale classification. Here it is. Now, in order to visualize if a new column has been created, we will go to the data view, and we can see that there is a new column with the name sales classification, and it has returned the low keyword against all the values since the sales amount is less than 5,000. Now let's change the threshold, and instead of 5,000, we can change it to 3,000 to see if the column returns the high keyword if the value is greater than 3,000. Let's go to the data view and see the column sales classification. We can see that it has written a mix of low and high keyword based on the threshold. This is how if allows us to perform conditional logic in our calculations. The last function is the Rankx function. This function is used to rank items based on a specific expression. For example, you might want to rank products by sales amount to see which ones perform the best. Here is the syntax of Rankx function. So first we have to insert the Rankx keyword, and then we have to give the table in which we have to rank the items. Then we will give it its expression, that is the value to rank by. Then we have to insert a value that is an optional case. This is the value that we want to return. And then we have to insert the order, that either we want to sort them by ascending order or descending order. The default is ascending. And then we want to insert the type, that how to handle these types. So the default is the dense. Let's demonstrate this with the help of example. Suppose we want to find the ranks of the products based on their total sales amount. Okay, so for this purpose we will calculate a new measure, and we will rename it as product rank. We will now enter our DAX formula that starts with Rankx keyword, and then we will insert all keyword and all function in order to remove any filters applied to this report. We will insert the column name product, and then we'll insert the newly created measure total sales, and we will insert the sort order that is descending in this case, and the keyword dense. This will assign the same ranks in case of tie. So we will now hit enter, and we can see that a new measure has been created. We will now want to visualize this, and for that purpose we will select the table visual, and we will insert the following columns: product, and we will then insert the total sales amount, since we want to rank products based on the total sales, and then we'll insert the product rank. Okay, so this is the visual and it is demonstrating the ranks based on the total sales. We can see that it has assigned the one rank to the product that has the highest total sales. We will now sort this by the product rank. You can see that it has sorted the table based on the ranks. Now we will remove the totals so that we have a clear demonstration of the ranks. We can see that it has displayed the results in the descending order, and but we want the number one rank to be present in the top row, so we will sort this by ascending order. Yes, this is how it has sorted it, and we can see that the product B has the highest total sales, so this function has returned the rank 1 to the product B. So this brings us to the end of the video. Thanks for watching. If you found this video helpful, be sure to like and subscribe for more such videos. Leave a comment below with any questions or topics you would like us to cover next.